this is Greg Carr. Today I'm going to show you how to scan a simple fossil with the NextEngine laser scanner. So here I have the fossil. It is a partial pinecone from a formation in eastern Oregon. It's a Miocene, so it's about 20 million years old maybe. And it's really pretty cool. It has underhangs, it has a lot of texture on it. I wish the other part of it was around, but I don't have it. So here's a NextEngine scanner. It's a laser scanner, and it shoots laser beams essentially out of the apertures. And then it has a turntable that moves around. It rotates. You'll see that later on. And it basically shines beams of lasers out onto the fossil surface, and then triangulates where every point on those laser beams are. So the first thing we have to do on this fossil is we have to put some index points on it. So this is a natural object. It doesn't have a lot of fancy sharp corners and things like that. And later on, when we go to index a couple of scans, we're going to need some reference points. So I find the easiest way to do that is to just take some white acrylic glue. I use this because it can be scraped off clearly. And I put a couple points on the fossil. Come on, squeeze out. I don't want to get a whole bunch out. There you go. I put a couple index points on it. Now, you may think, why am I putting white on white? Well, that's because I want to be able to take these points back off later on. And to do that, I want something kind of soft. So this paint actually scrapes off rather easily, or you can also remove it quite well with acetone. And it does not damage the surface of the fossil. And then, so this is kind of a background, and then I will also take a black magic marker and make a black mark on the surface, on those little dots, to really focus in on it very closely, because you'll need that during the alignment process. So we'll let that harden, and I'll come back in a couple of minutes. Okay, now that the glue has set for, or the paint has set for a couple of minutes, I'm just going to put some little tiny black dots on the center of those paint spots, and that'll give me some pretty accurate things that I can see later on. Okay, so now I have my marked. It's very important to do this before you start, because once you start and you don't have those marks, then you've got to completely do the rescan again. I have found that out due to sad but true real life. So, and you mount this thing on the turntable. Basically, you have a little mechanical arm here that you can use to hold the top down so it doesn't shift. It's important that it does not move during this process. And basically you center it roughly. The scanner does a good job of piecing the things together afterwards, so you can be a little off center. It doesn't really matter. One thing that is useful to do is that you think about what you're going to do. Now, when you scan it, the scanner, of course, cannot see the bottom or the top of the fossil, and so you're going to take a preliminary scan, or going to take one scan in this way, and then you rotate your specimen 90 degrees or so, so that what was the top is now the side. What was the top is now the side, and you can scan that. That gives you a full 360. for this specimen, I'm not really too interested in what the backside looks like. It's just basically this pine cone on the front. So I'll scan the front from about three directions at very high resolution, and then I'll scan the rest of it at a lower resolution, just because there's no need to scan this part of this broken rock at 50,000 points a square inch, where I really do want to scan this side of the rock at 50,000 points a square inch. So we'll fire up the software. Oh, and the other thing is, while it's scanning, of course, this bar that holds it up interferes with scanning the backside, and you'll get parts of the scans that don't show up real well because of the bar. And so it's always good to put the less important part of the specimen toward this support bar. That way, you know, if I don't really care what this back is, I don't care that it might not be perfectly scanned. It's the front with the pine cone that I really want to scan well. Now, if all parts of it are important, all parts of the specimen are important, then you might want to scan one with the one side here, and then when you rotate the specimen to scan the poles, the upper and lower part of it, you might actually rotate it in the z-axis as well, so that all parts get equally scanned on the clean side of the scan. So we'll stop it now. So I have the NextEngine software running here. I'm going to start a new scan. First of all, I have to decide where I'm going to put this file, since these scans have many individual files in them. They have to take lots of pictures and stuff. I normally create a new folder for every scan that I do, or every specimen I do. So in this one, I'm going to have a folder just called pinecone. And of course it's empty. So on the NextEngine, I will go ahead and hit the green button that gives me a scan. And when you are doing this, you have a couple of things. One is you want to be able to have the object roughly in the middle. I always start out with the flat object pointing toward the cameras back here on the scanner, and roughly centered in the middle. So you can see it's roughly scanned, roughly in the middle of this. It doesn't have to be totally centered, but that's a little lopsided. Sorry. So there we go. That's a little bit better. Now I'm going to set this scan up as not, they have lots of options. I'm not going to try to teach you everything here, but I can basically go all the way around the item. I can do what's called a bracket, which is 3 scans around, starting in the middle. And then I can do just a single scan. So for this one, what I'm going to do is I'm going to set that up for quite a few. The divisions is how many positions it would take if it was going all the way around. So if I was scanning the whole outside, I would do it 16 times. But I'm only going to do it 3 times, and I'm going to do it, this is what we call the range. And macro range means basically the specimen is real close to the scanner. The specimen is, ideally the center of the specimen is about 7 inches from the scanner face, and I have it set that far. Now you can also do it further away. I can do a wide scan, and that is about 18 inches away. That gives you less resolution, but you can handle bigger objects. In this case, that's not what I want. This is a small object. You can see it fits in here very nicely. And I'm going to scan this bracket at a very highest resolution I can get, 40,000 points a square inch. So I have a few indicator points, my 3 indicator points that I've put on the face here. I can see them quite clearly, and that's important because when I align this scan, since it's not a full 360 scan, I will have to pick out those 3 points. But 3 points are enough to define an object, a point in space, and that's what this software requires when we're doing our matching or our aligning. So I'll go ahead and start the scanning. And it goes back and it starts the process. It makes sure that the scanner makes sure that the object works. I'm going to go turn off the ambient light here. So it'll do a calibration scan, and then it will start sweeping. See, there's your laser beams. It will sweep that across the face of the specimen very slowly, meanwhile triangulating every single point on the surface of that specimen. It won't get the wall behind it. It doesn't focus back there, and it has a limited depth of field, as you would say. But you can see that the bars of laser light are sweeping across the face of the object. And it will do this. It takes, to do these 3 objects, these 3 scans, is going to take about 10 minutes, so I will put it on hold till they're done. Okay, so it's been a few minutes, and our scan, that first scan has been done. You see we have a picture of it here on the software. I can actually rotate this around, but you see it has no backside. You look at it, and it's looking at the front from the back, sort of. This is not a 3-dimensional model yet. So what I'm going to do to get the best possible scan of this pine cone, I am going to rotate it 90 degrees and rescan the front side at the high definition, because there's some pretty interesting holes in here. But I have to use both hands, so I will put this down and do that rotation. So you see I've rotated this specimen. I particularly want to see if there's anything I can capture back on this side. So I want to scan this side and this side at high resolution. The way I'm going to do that is I'm going to start out with it at an angle like that, and then hopefully I can scan this at 40,000 points a square inch and get a better resolution. So what I'm just going to do is go to my software and do scan again, and it knows it's all the same specimen, so it's all the same sample. So here you can see I've got I got the pine cone on its side, and I'm going to go ahead and scan it again. I'll just go ahead and start it, and it will go through that same scanning process and generate a new family of images. This image, this is the one I just scanned, and you can see I have 3 images on it. Now I'm going to get another 3 images off of this scan that I'm doing now, and then I will do an overall scan of the whole block at a lower resolution. I've decided to repeat that last scan. There's a lot of these deep holes in the fossil don't appear to be scanning properly. So I've used basically baby powder to fill them in very lightly and then brush away the excess. And so that should give me a better resolution of down in the pits there, where it must have been a little too dark for the scanner to pick it up. Okay, so now the scanning is done. I've had my second time around in this orientation at a high resolution. Now what I'm going to do is I am going to rescan this at a lower resolution and do the whole thing. So we go back here to the scanning thing, and I'm going to set it up. First of all, I choose to use a 360 scan. Then I go back to, instead of high definition, I'm going back to the lowest standard deviation. So we, at highest deviation, see, we got 40,000 points per square inch. At the lowest standard deviation, I've got 1,000 points per square inch. So it's much, much smaller file size. And it's of things that are not important. So one thing I'm going to do is reset this a little bit so it's centered. I have to just physically move it over. You see, now it's centered. And I'm going to go ahead and scan this whole thing. At the lower resolution, 16 divisions, which is quite a few. I don't need that many. I think I'll go back to about 12 divisions. So I got my 12 divisions. I'm still on macro, which means I'm still close to it. Neutral color. I leave the holes all filled with the baby powder, and we'll go for it. And so I'll put it on pause again, and we'll see how this scan comes out. Okay, so now we've scanned the whole object at a low resolution. We'll scan it again at 90 degrees at a low resolution. So that way I have the whole fossil done. Oh, goodness gracious. Thank goodness they're not fragile. So then we'll get the whole fossil done, and that'll give us all the sides on all the okay, as I was saying, so now we'll do it at post it up here at 90 degrees at a low resolution, so we get all the sides done and get the whole thing then pieced together. So while we're waiting for the scan to finish, I can go back and start trimming these previous scans. Now, if you look at this scan, this was the first one we did, high resolution. It was just the front face. If you look at them, so we, it doesn't have any backside because we didn't scan that, but it has extra stuff on it. This is part of the support that was holding up. This is the turntable it was on, and those are not anything we want to have. So we have a command here that's called trim. And when you go to trim, it'll save a backup file. It's named, before trim or something like that. And that just kind of, I guess it's kind of it's a checkpoint, so that if you don't trim it right, you make a mistake, or you take out something, normally you can reverse it, but on trimming, once you trim off a part, you can't untrim it. You can't reverse that part. The only way you can go back is to a previously saved version of it. So you click on, you've got different sizes and shapes of things that basically it's like an eraser. If you're familiar with eraser from other programs, you just highlight the part that you want to take off from the scan, and it will change color. If you want to take it off, it'll go green, red. And if you don't want to take it off, you can add it back in before you hit the trim button up here. Once you hit the trim button, this stuff's all gone. So you want to kind of look it over and make sure you're taking off what you want and only what you want. So that looks pretty good. I'll go ahead and trim that off. So there we go, that's trimmed. And we'll go over here and we'll do the second file, which was another high resolution version we made. And again, we will trim off this stuff at the bottom. can do the low resolution file. This is the one we're not currently scanning. This was a high resolution that we made with the baby powder in it. So we're going to go ahead. We'll get rid of this stuff here and the scan at the bottom. This one shouldn't have any back to it. That's another one of these front scans. So this was a little tiny bit of the bottom, but we'll get a clearer version of that when we scan, when we're scanning the whole object. So we don't need that. We'll just go ahead and trim this off. And it will vanish. Okay, so now we have our scan somewhat trimmed up. You see we have a little bit of garbage right here floating. The software does some of that. We'll remove some of that when you go to fuse all these things together, but I prefer to keep it a little cleaner. The software doesn't do the best job on these things. Okay, so I have trimmed up these. I'm currently scanning this one. This one is the low scan that has the whole object in it. Now you can, one thing I can do here is you can change what the object looks like. This has the object in 3D in color. Here it is as just as a kind of a blue object. And you can see, so this is the kind of scan you'd get. Again, this is a low resolution. So if I zoom right in, you could see the triangles in it. But I've got the support material here and stuff. So I can go ahead and highlight that and erase it. We'll go back to trim. And again, it has to save this before it'll allow me to trim. Okay, so I can trim, I can highlight all these things I want to have removed. There's lots, they have several different tools you can use to select this. I just like to kind of treat it like an eraser and go through and erase it all. But for example, if I wanted to make sure I got all this stuff here, I can actually just kind of circle a whole area. That way all the little loose stuff that was in there would have been highlighted. I'm going to get that top part and we'll trim that off. I see here there's a little tiny dot left. We'll trim that off. You can zoom in and move things around. Sometimes you can see the dots, the little spare 1 or 2 pieces. See, there's a spare there. That needs to come off. So this is, I mentioned if you do the backside, sometimes you don't get the, because of the bar that goes up and down, you don't get an accurate scan, and you can see a clear evidence of it here in this low quality scan, or not low quality, low resolution scan. So this is some garbage. We'll go ahead and take that off. And we have a whole slot here that didn't even get scanned because of the bar that went up in front of it. But that's okay, because it's more important that we get some of the back and we'll get this. We have the other scan that we're doing, and those two will fit together and get almost the majority of this whole block. And it will also, we can use it to, I mean, when you fuse all these together, it puts holes in it. Now, one thing I'm going to do here, this scan is a low resolution scan, and when I take the high resolution front ends and merge them together, this low resolution part will interfere with the good high resolution part I want right here. It doesn't matter out here in this stuff, but I don't want it to average any low resolution stuff along with the high resolution. So I am going to erase all of this low resolution from the pinecone part, imprint, the part that I'm trying to get. So I'm going to go ahead and erase a lot of this. Now, when I erase a front part here, one of the problems is it also, imagine this is a bullet hole. It also does the back part. I don't want to lose the back part. So I set them off to the side. So this was the front and this was the back. And I unselect the back part so that it keeps the back part. So I will go through and I will select all this. I want to select all this front part that has the pinecone in it. It seems kind of wasteful to scan it all and then take away the parts you don't want, but that's the limitations on this one. There are other programs that you can use that will only take away the front surface and not the back surface. But this program from NextEngine doesn't do that. So you have to realize that, okay, so I'm erasing all this, but I'm also erasing everything that sits behind it, and I don't want to do that. Luckily, there's some spatial they're far enough apart that I can merely rotate it and then unselect everything in the back. Let's see. Probably easiest if I just go like this. This is one that lets me do kind of a whole bunch of, oh, well, that's not quite what I wanted, but. There now, so I've removed all of the scan, I think, of the pinecone. Sometimes it's easier to see things if you make it blue. So I've moved all the scan of the pinecone, and we'll go ahead and erase that. So I've left a big hole, but that's okay. I've still got a good part of this that I will use to match up with the other parts. So I'm still scanning this one. This one, you can see I've got 3 blocks done. There's another 3 more to go. I'm not going to trim this until it's done because it keeps writing things over here since it's an active scan. So we'll put it on pause, we'll wait the scan finish, and then I'll show you how to align all these different scans we've done. Okay, so now we have the second low resolution scan done, and I'm going to go ahead and clean this up. Oops. I want to red it out so that it vanishes. Okay. So now I have all my different scans, a couple of low resolution scans. I'll take and I'll trim the pinecone out of this low resolution here as well. And then I'll start aligning it. I'll do this on a different, another video. My camera's running out of battery. Anyway, here we are back again. And I'm going to show you how to align scans. So we have these 5 scans. A, B, C are done at high resolution. D and E are done at low resolution and have the um, and have the whole of the body. So we're going to select A and B, and we will go back to align, and that brings up these two scans side by side. And what we're going to do, so what I'm going to do is I'm going to just set them up here parallel, and then I am going to select, I put dots on them, on those indicator points that I had painted on. And you got to get them in the right, in the same points, of course. If you don't, then the model will crash when it tries to align it, because there's no correspondence between the scans that it has and the and where you put the points. You notice these little points too, also because there's so much different color, they're very dark. They often have holes next to them that you have to avoid, because otherwise you put your dot down and it falls through the mesh. So now I have those all done. That's good. Now I can select the next one and again repeat the whole process. You can either put the points on, same color one after another, or you could put all three on one side and then the three on the other side, as long as you know what you're doing, which one it is. Okay, so I have 3 points there, 2 points, here's the third one. Just get that one over there. Okay, so I got those two scans aligned. I'll go put, I have this scan and this scan. This is the one that has the low resolution, that has the pinecone cut out of it, but you see it's still, I put those dots far enough away that even cutting the pinecone out, I still have the dots left. Very important to do something like that. You got to have at least 3 dots. Okay, and the last one, we'll do the same thing. Okay, and then since I have dots on all these things, everything's going to be aligned in one fell swoop. I hit the align button and nothing happens. So sometimes there's a bug on this. So I go over here to align and hit start, and then go hit the align button. And it takes off and it starts aligning. Now this will take a few minutes to print, to align it. So we'll pause. Okay, so we've got the thing aligned. If I look at it though, I see there's a little bit of a floater here of some sort, and you probably can't see on the camera, it's a little tiny one right here. So we're going to have to go back and trim those. So I just, like I did previously, I'll just select the areas to be trimmed off, cut that off, cut this off, whatever it came from, trim. It won't take very long. Now, if I go over here and look at this part, I can actually look at my triangles. And you see that what we have is an incredible mass of triangles. So all of those scans have been laid on top of each other, but they are all still separate scans. And so if I go in here in every place, I've got 5 scans. I will see in most locations either 3 or 5 layers of mesh. And that, of course, is not anything you can do with. So what we have to do is we have to fuse these all together. So you hit fuse, and what it does is it basically takes, I don't know the magic that they use, but they take and they figure out the best place to put one mesh instead of all 3 or 5 meshes, and we end up with one mesh that defines the outside of this object. So again, we'll put it on pause and wait till it gets done finished. No use you guys wasting your time. Okay, so here we have the item all fused. I have found that if you just fuse it once, they end up with a lot of errors in the mesh. And other programs have problems with all those mirrors. But if you hit fuse again, even though it's just fusing one layer of mesh, it greatly reduces the mesh errors and makes it much easier for subsequent programs, such as your slicer program or something, to handle the mesh. So we've gone through and meshed it twice. That gives us a final scan. If you need to save this into whichever folder you want. If I look at this scan, I have it in blue just because it's easy to see. I got all the sides there. The back part here is noticeably smoother than the front. That's because it was scanned at a much lower resolution, and it's going to end up being much smaller. But the part right here with the cone in it is scanned at a higher resolution. You see we have a looks pretty good. If I were to look at my triangles and then zoom in on this particular area, if I zoom in on the back side here, you can see I have triangles. It's pretty interesting how the process works. But so I've got triangles of different sizes. And if I go in and look at the front part, you see I have many, that's the same scale. I have many more triangles as they basically drape over the surface. So this is, this front is, this area with the pine cones, oh, come on, is scanned at, 40,000 And actually the whole front is scanned at that. And then the backside is at 1,000 per inch. So that gives you a NextEngine file. You have to output it as an STL file. Most of the things are done as STL files, so I'm just going to call this a pinecone. And it asks you if you want it binary or ASCII. Do binary, they're much smaller files. Hit it done, and voila, our STL is filed, and we can go look at it in other programs and import it, do different things. This is Buelah Fossils pinecone. I'm going to have to change the name, pinecone STL. So we're importing it as a pinecone. Well, it's an STL file, it's a stereolithography file. This will take a few seconds here. So here it is, pulled into Meshmixer, which I find to be a very useful tool for managing the meshes. If you look at it here, you see in Meshmixer, you've got these little blue dots. Well, these are errors that are still existing in the STL file, even though I've ran it through and fused it twice. So to fix that, going over to Analysis, Inspector, and it'll come up with all the errors. Oh my goodness, there's so many errors, but actually it's not that many. And this will successfully repair it. If I had only fused it once, many times there are at least 10 times more errors. Here there's 1,900 errors. I could expect to see tens of thousands of errors if I only fuse it once. So there we go, all fixed, hit done. And we have our fixed STL file. In you see, we still have some. We have some indication, but the block is just a block. Now you could take and you can digitally cut this smaller and extract just the pine cone from it. It's kind of nice because it is the whole block of rock sitting there. You see, it's not the same size. Well, yeah, it is. You just scale it. Actually, you just zoom in and look at it. And we have a reasonable capture of all of the little holes. You see, we got a little hole here where there was part of the pine cone sticking out in here. So it's not perfect. I mean, you can't. The only way to get a better impression of this is to make a silicone mold, which is bothersome and not worthwhile. So one thing I didn't fix on the other file, you see this little dot right here, this little wrinkle in it? That's actually an artifact of the paint dot. The paint dot came up as a hole in a hill. So I could take and fix this a number of ways. I can fix it originally in NextEngine, or I can do it now merely by, we can just select it with a very small brush. Well, not quite that small. Just make it about, I can select it with that brush. I can delete it. Now it's left a hole. I just go back to my Analysis and Inspector. And it says I got a hole, and I auto repair all. And it took care of the hole. You can see kind of a circular artifact there, but at least it's not that little bump. So anyway, this shows you how you can overall take and scan fossils with a NextEngine laser scanner to various degrees. You can scan the important parts with different resolution than you do the non-important parts. And now if I post this someplace, other people can take and print out copies or examine copies of this fossil. And by the way, this is a Miocene, somewhere between 5 and 25 million year old pine cone. Comes from the Buelah Reservoir in eastern Oregon. Was collected, this is this great car, and I'm doing this at the end of September. It was collected about a week and a half ago in Central Oregon. So anyway, enjoy.